In this problem, for the function f of x equals x to the third minus 12x plus 1, in part A, we're going to find all values of x that correspond to horizontal tangent lines. These values occur where the derivative is 0, which explaining about the horizontal tangent line. Recall the tangent line, the slope is the derivative or the f prime of the x, and the slope of the horizontal line is 0. Therefore, the hint of this problem is to find the derivative and set it up to be 0 and solve for x. I'm going to put a note here for the part A. We're going to find x where f prime of the x equals 0. And then for part B, we're going to use the values from part A to find the open intervals on which the function is increasing and on which the function is decreasing. So starting from part A, we're going to find x where the f prime is 0. For the function f of x, which is in the form of x to the third minus 12x plus 1, first we're going to find f prime. The derivative of the function f is 3x to the second minus 12, and we let it be 0 to solve for x. So the next step, we're going to solve for x. Where the f prime of the x equals 0. The f prime of x is 3x squared minus 12 equals 0. To solve for x, I see the common factor 3 and 12 to be 3. So 3 multiplied by x squared minus 4 equals 0. Factor completely to get x minus 2, x plus 2. This way, I can see I have two numbers, x equals 2 and x equals negative 2 will give us the f prime of the x equals 0 or the horizontal tangent line will occur. And then the next part for part B, we're going to use the value from part A to find the open intervals where the function of increasing, where the function decreasing. For this step, we are going to use the real number line to represent the sign of the derivative of the function. So we're going to use the real number line. We're going to draw the real number line and locate the two numbers that we found. The derivative gonna be 0, then negative 2, positive 2. And this line we call represent the sign of the derivative, which is 3x to the second minus 12. And since on the way or the process of finding the value x where the f prime is 0, we factor this completely to be 3 times x minus 2 times x plus 2. To locate the sign of the derivative, we know at negative 0, the slope is 0. At positive 2, at x equals negative 2, the derivative is 0. At x equals 2, the derivative is 0. How about the value of the x that's greater than 2? For any x is greater than 2, let's consider the sign of the derivative. So the f prime gonna be the value 3 multiplied by some quantity greater than 2 minus 2, you're gonna get plus sign. Some quantity greater than 2 plus 2, you're gonna get another plus sign. Therefore, you have, let me clean up this real quick. So the derivative for the quantity greater than 2 will give us the 3 multiplied by plus sign multiplied by plus sign that return positive sign, or on this interval, the slope gonna be positive. And then for the second interval or the one in the middle, between x equals negative 2, and x equals 2. The derivative gonna be as the sign for the 3 multiplied by the sign of the number between negative 2 and 2 subtracted by 2. For example, you pick the number 0. 0 minus 2, the sign will be negative. And the number again 0 plus 2, the sign going to be positive. Therefore, it will return the sign negative for the f prime within this interval. And then the last interval going to be the number that is less than negative 2. For less than negative 2, the sign of the f prime, which is a sign from the 3 multiplied by the quantity, which is less than negative 2. If you pretend like x equals negative 3, negative 3 minus 2, that's negative. Negative 3 plus 2 going to be another negative sign. So overall sign of the f prime within this interval going to be positive sign. So now we have positive sign for the f prime for the interval that less than negative 2 and the interval that greater than 2. The sign negative as a derivative or the decreasing graph will occur for the interval negative 2 and 2. From part B, we're going to use values from part A, which we already did. Find open intervals on which function increasing, function decreasing. So we're going to wrap up as a summary of this part B. So the function is increasing in the interval negative infinity, negative 2, also to infinity, and decreasing in the interval negative 2, positive 2. So over here, negative 2, positive 2, and then the rest of them gonna be like the left and the right end of the graph. So on the diagram that you see on the bottom of the page, at negative 2, you have horizontal tangent. At positive 2, you have horizontal tangent. On the left side of negative 2, the graph is increasing. The graph is increasing. And then also on the right side of positive 2, between negative 2 and positive 2, the graph is decreasing, or the negative side of the f prime occurs between x equals negative 2 and positive 2.